applications. This help us to understand those application raw material selection in detail. Okay, first application we are talking is about anti-static. Anti-static meaning in our childhood days we have seen when when we take a scale and rub it on our hair on the cloth and we show to some paper, it started attracting. I think everybody might have seen that. Okay, this means some amount of static current is building up in the plastic part. This is a property of insulation. Whatever insulator material have this property of accumulating a static charge. But even in our molding shop, if we go and see, when we are running the mold, small parts and all run continuously, and suddenly somebody is going to handle the part. We are picking the part from the crate. Suddenly, we'll get a shock. This is because static current is building up inside the insulator part. So what is the issue due to this? One, okay, there is a chance or some amount of shock to the people. And most severely, when the application, this product is used for some electronic part, handling electronic parts. If you are keeping these electronic parts in some plastic, something like this, I will show you. This is an application. This is a container which take care of like a crate for an electronic part. If static charge is there inside, normally this happens in an electronic assembly unit. This
mobile phone units.
Mobile, absolutely correct. Mobile phone unit or any electronic units. Or memory stick manufacturing unit. All these things. So there is a chance that the electric current, but the static charge inside the plastic can damage some of the sensitive electrical small chips or something. So on those place, they don't want to electrical static charge to accumulate on the part. For that reason, anti-static material is being used. Base polymer could be anything, but there is an additive added to that, like carbon fiber, carbon powder, stainless steel fiber or something, so that anti-static charge, it will have lighter amount of conduction, so that charge will not accumulate. These are some of the other bins example, and this is also used in clean room production. The shoes is used in clean room because some static charge is there, means dust will accumulate, it will attract dust. Even similar to when we are using a plastic fan, suppose our fan normal fan itself, after some time some type of dust will accumulate. If you see plastic fan, it is rotating, so there is a chance of static current to accumulate in that. So so there is a high chance that it will accumulate the dust and it will become untidy very easily. All the dust will just get attracted and accumulated. To prevent that, anti-static agent is being added during the processing or compounded to the raw material. So multiple these, you can see our gloves, and safety gowns or whatever gowns we are using in hospital atmosphere or wherever in a clean room are anti-static. In sole of shoes and shoes hole itself, and the mat which we are using in a clean room production and all, otherwise dust accumulation will happen. And even the cover of this the electronics product, all these things are anti-static. Now we come to anti-fog. What is fog? If it's a transparent part, we are using a transparent application like helmet or eye wear or swimming wear, swimming goggles. And nowadays in corona time, many people are using safety goggles also. So whenever fog happens, the clarity, the vision will be it will be hidden, like the fog will come and settle on the glass or the transparent thing, and see through will be a difficult thing, as you can see in this picture. So this anti-fog thing is an additive, okay, which is added into this raw material when we are processing. It will a small additive, maybe like 1%, very less 0.5% will be added, so that accumulation of that fog will not happen. How it is done? This it is based on the basic raw material. What base raw material? Based on that anti-fog material, additive will be selected, and it goes in when we are molding, we'll be mixing it and molding it, and after some time it starts coming to the surface. Slowly it comes to the surface matrix of the the part, and whenever some fog is about to come, it cools down the fog and it will become a droplets of water, or it just flow down. instead of making tiny droplet, it combine it all these things, and just it comes out, come down, so that clarity will be maintained. And even in the food packaging, no, food packaging industry, we are seeing the shopping mall and all, this application very important, films and all, this is very important, because it doesn't look good when no everything is hidden, we are not able to see what is inside that package container. So this is a very important application. Basically, majorly go for packaging industry, transparent packaging industry. Overall, to eyewear and to all swimming, wears, all these things. And this is a flame retardant. No, I shown some of the example of flame retardant additive. We have discussed flame retardant means if the part catches the fire, how quickly it should extinguish. This is the flammability property. Basically, inside the raw material, generally this comes inside the raw material itself. Suppose polycarbonate SABIC grades, we are telling 123R is a non-flame retardant, but 945, 943 is a flame retardant V0 grade. Means it quickly extinguish the fire. How it happens means the additive inside the material come whenever overheated, is about to fire, it sends it and it comes out, the fumes comes out and completely cover the part, so that it disengage the contact of the part with the atmospheric oxygen, and oxygen is gone, then burning stops. This is how it functions. So we can see like busway, a lot of electric busway is there. This is a connector in this PBT. Normally so much higher electrical application, thermoplastic like PBTs are used, or thermoset also used. Thermoset is extremely good for electrical application. All the good electrical properties, thermal properties are there. Okay, dimension stability is there. Then PBT nylons are very good. PBT glass fill. Sometimes PC PBT also used when we want a higher dimension stability. Yesterday we had discussed like PC, and we have to have a better chemical resistant or electrical property like PBT. Then we'll make a blend and use these products. These plug sockets are PBT or PBT PC blends. And mobile phone chargers are made of fire retardant grade polycarbonate. V0 polycarbonates are being used. And if very low type of products, we are ABS fire retardant also comes to picture for mobile phone application. But majorly polycarbonate is used by due to the regulation, because polycarbonate have a better impact strength. These products call for a ball indentation test of 125 degree. So ABS cannot withstand 125 degree ball indentation. Only polycarbonate can be withstand. That's why this this type of products polycarbonate is used more than electrical property also. And when we come to other thing, metering solution like electrical meters, very important. Fire retardant transparent metals are used. It little bit costly, because whenever we normal add fire retardant to any raw material like PC, it loses its transparency. So suppose we have a opaque part, how the flammability will be described like V0 at 1.5 mm. It is what thickness this will have a flammability effect. V0 at 3 mm, V0 at 3.5 mm, V2 at 3 mm, like that it is. So lesser the thickness, and we are telling it is V0 means it's a tough fire retardant grade. But when we are going to a transparent material, okay, generally we will not get a transparent material which has higher flame retardant rating in lower thickness. So I have a opaque polycarbonate easily available 1.5 mm V0, but transparent very difficult to get. Normally 3 mm V0 will be available in the market. So then we have to design the part as per the 3 mm to get if we want the V0 itself. That's how it is done. And very few materials are there. There are materials which are V0 at 1.5 mm or 1 mm in transparent also, but they are very costly because of the technology. Because the moment we add fire retardant, it loses its transparency. Normal fire retardant, they use specific fire retardant which are very costly. That's why those materials are very costly, and there is a chance little bit increase in the brittlety also, brittle nature. Then comes the semi-crystalline fire retardant application. Everybody knows this application is a battery container, battery of automotive battery, our UPS battery. All these batteries are made of PP, but PP by itself is not a fire retardant. Then People compound it and add fire retardant. Generally, the manufacturer itself compound, many manufacturers itself, because it's a cost sensitive market. So we'll buy normal PP and fire retardant, and they will compound based on their application, and together they will compound the color also. Some are dark, green color, red color. You have seen bigger players in the market, and based on that application, the what is the amount of fire retardants you require, that based on that additive will be added and compounded to that. Next application is MCB, very, very critical application. So in this, mechanical property also very important, fire retardant property also important, even dimension also very, very important. So electrical point of view and mechanical, or it's a cyclic, some type of cyclic can come, and thermal temperature also can increase. All these things put together. That's why normally for this application semi-crystalline is used, but semi-crystalline unfilled will not give a dimension stability. So here in MCB, like sometimes nylon or PVT filled, like mineral filled are mostly used. Mineral filled, highly white in color, mineral filled materials are used in this case. Sometimes some amount of glass is also added to this product. Most of the MCB parts are made of PVT or nylons. If we are doing in nylon and all, still design, maybe people who can do design in such a way that they can take care of all the CPS things and all properly. Here in MCB you can see like Schneider and all use nylon grades, fire retardant grades, filled grades for this application, because nylon has, even the cycle time of nylon can be reduced very less. But it is a challenge for making the tool, basically the tool running the part. So everything, Devendraji, day before yesterday has spotted this point. Running a nylon is very critical. So they know how to run, because specific machine is being planned for this application. Robots are there will not be any loss, stoppage. It will be continuously running. Mold itself is made so much robust, and inside the mold is they put a lot of beryllium copper, not touching the part, below the part, and water line and oil line will be passing through that. So quick cycle time and very, very thermally robust mold will be made for the application. Moreover, those materials have a tendency to due to the fire retardant property, especially in semi-crystalline, they produce some fumes, and some amount of sediments will be accumulating in the mold and blocking our air vents or the pin, ejector pin and all. So they make the mold in such a way that venting and all, very, very huge amount of venting will be there. Some porous pin will be provided, so that whatever gas is happening, if gas is accumulating, then what happens, burning mark can come. Even small black dots is a rejection for some of the major manufacturer of MCB. So they'll put lot of air vents, and in periodical maintenance. How do maintenance is, they'll lot of small insert. The mold will be made of insert construction, complete insert construction. Many small insert they will make, the maximum the better. In that way the mold will be made. Moreover, after like one shot or something, mold will be down, they will have a spare mold, and this will be cleaned by ultrasonic cleaning. Ultrasonic cleaning of mold means the insert will be removed. Each and every small insert will be removed. There will be a ultrasonic cleaning machine, in which there will be a liquid will be there, and the inserts, metal insert, our mold inserts will be putting inside that, and it will be vibrating in a higher frequency due to ultrasonic frequency, and the cleaning happens. Otherwise, if we are just cleaning with the cloth or rubbing, sediments will not go out. This is why those processes are employed in such type of molds, okay, critical molds. And then comes a ACB, air circuit breaker. This is the first and foremost safety device when we are entering to any factory or where a huge amount of current is being used. The body, the outer area of this product is made of polycarbonate. Some most probably higher grade of products are made of 10% glass fill polycarbonate, fire retardant grade, V0 fire retardant grades. And inside maybe there will be nylon or PBTs, but outside wherever impact can come, impacts, and somebody there is a chance for hitting with something or something, then, and aesthetically also should be better. So polycarbonate or polycarbonate basically majorly used by the top class manufacturers. In this there will be pad printing, okay, pad printing will be there, so stickering will be there. So whenever we are using, we have to see the sticker or glue, whatever is sticky, is compactable with polycarbonate. And next comes the application of switch industry. Major switch manufacturer use polycarbonate, and some use ABS also. Premium people use polycarbonate. Why? Because aesthetically it's very good. We can go for a higher shining application. Polishability is very good, and polycarbonate has a very good diamond stability. And have, when we add a flame retardant, by nature itself it can pass 850 glow wire temperature, polycarbonate. But when we add fire retardant, it has a capability to extinguish very quickly. Like V0 grades are available wherever electrical conductor is coming. In switch industry, wherever electrical conductor is coming, like some connector or plug or something, they use V0 grades, V0 fire retardant grades, which are higher in flammability, quickly turns off the fire. And wherever it is not there, like a knob or something, where there is no electrical conducting passing, they use V2, next bottom grade, or V2 or V1 grade. Okay, these are metal is selected. So bottom backside of a switch, wherever all the terminals are there, there V0 grades or PBT fire retardant grade will be used. But front area and all polycarbonate is used. And this is a relay, relay, electrical relay. So bottom side we can see, though, here in this PBT glass fill or nylon glass fill, flame retardant will be used for this application. And this transparent area, normally polycarbonate fire retardant is used. Or in this case, polycarbonate copolymer is used because some relay manufacturer make this relay cover at 1 mm thickness. Okay, and they want a V0 at 1 mm. So as I told, normal polycarbonate transparent will not serve the purpose. Then they have to go for a special copolymer which can give a V0 higher flame retardant rating at a lower thickness. So this is a special application for relay, because normal transparent polycarbonate has a V0 at 3 mm of thickness. Okay, but when we are designing this part for a 1 mm thickness, we have to, as per the regulation, as per the safety, we should take a raw material which has a certifies, or it has a property 1 mm V0, okay, instead of 3 mm. And this is a product, Devendra, this product like solar connector. Here it should have a higher weatherability property, it should have a lower water absorption property. Along the couple, it should have the flammability property also, since lower moisture absorption, because these products serve, continuously serve, and they ask for 25 years service period for solar products. It serves in a humid, at any humid atmosphere. It can be humid any atmosphere, and also it could go to a higher temperature in a desert atmosphere also. So they are asking for material which have both the property, like Norail. Okay, Norail is being basically used for this application. There are some another material also available, mostly used by Norail, but there are some other material also available, costly solutions which goes for this application. And this is a back case of a electrical torch or something, chargeable torch. Oh, here it calls for backside, there will be heat sink. Okay, so it calls the temperature rise will be something around 90 degree, and so that and electrical property also should be there. So using polycarbonate with flame retardant, and polycarbonate can withstand, as I told you, 115 to 120 continuous use temperature. So that also, this is the back part of an electrical switch. So here they are using some are using polycarbonate fire retardant property, or if it's goes for higher ampere, or suppose this is 16 ampere switch, polycarbonate is okay backside, but it goes for 32 ampere socket, which where we are putting a heater or geyser, our microwave oven or something, 32 ampere higher current, then polycarbonate is not sufficient. Then we have to go for a PBT glass fit. Then only it can be, it can go up to 160 degree of continuous use temperature, and electrically more electrical property, it will not burn away also. This is how material selection has been done. This is water management application. There are multiple water management is wherever water is coming in contact, a lot of application. One we have shown last picture itself, there's a electrical cum water management application, like Norail is being used. So here, see, this is a impeller of a pump, especially in a borewell pumps. There will be stage pumps. How the borewell pumps comes, the more the deep, the number of stage keep on increasing. You can see when we are going for 100 feet depth, the pump, the motor pump, you have seen borewell, not like a tube. So its height will be suppose 1 meter. If it goes to 500, then it goes to 3 meters. It is like that. Stage keep on increasing. So this is what, no, this is the impeller. Impeller keep on increasing when we go stage by stage. This is a normal monoblock pump. In this, some of the small pumps, even plastic is been. Basically, nozzle is used. So most of the cases, filled nozzle, 20 or 30% nozzle is used, which has a can go up to operation temperature 135-degree continuous use temperature, and has a least moisture absorb property, just 0.1. And moreover, it has very high dimension accuracy ability because it is an amorphous. So it has a mixed property of all the things. That's why nozzle is used. These all are the pump parts. Here you can see a commodity application, a water tap. Here normally ABS is used. Some people use for PVC also. Top and all, PP. This one transparent, semi-transparent thing is PP used. Others are made of ABS. This is a little higher end type of facets inside the pipe. No, you have seen earlier it was like brass. Now some of the countries they are using plastic also. But what is the condition when we are using plastic? We cannot use a PP or ABS because temperature withstand should be there, continuous use temperature. Then there should be some metal which can withstand it. Like sometimes people use highly extreme metal which can go up to 180-degree, or people use Noreld GTX grade also. Like Noreld GTX means it is a combination of PPO and polyamide and glass fill. So such grades can take up that type of pressure and temperature also, because hot water can come through this. Okay, so instead of brass, they are replacing with that. Still, no research is going on type of heavy application in plastic. And this is like a spray shower in which plating is required. Then normally, ABS type of plastic is being used. And this is a valve. Okay, which we can see heavy duty valves, or something. Normally in this application, the this body and all is made up of PVC. We have seen all pipes are made up of normally PVC. Thick profile can be made very easily, and it requires all in the mold big gates and all. But it is very good molecular weight material and having very good strength. And whether when UV additive is added, it has a very good weatherability also. We have seen our pipes and all staying in sunlight for years and years, walls without any damage. Inside the valve, there will be a pocket which closes and open. Generally, it should have a lubricating property. So, Delrin POM is used for that sealing application or lubricating application in that inside the valve, closing and opening. That is done by POM. And then comes this is a water meter. Generally, in India, we can see water meter is based on made up of brass or something metal, because still our regulations are not modified because earlier generation it was brass only. So still it is India brass conversion manufacturing are much lot of people are there. So regulation also not changed, but Europe and all regulations are added up because in brass there are lead content is more, so they have a much stringent regulation. So due to lead content, they are they have shifted to plastic, because in this metal lead content issue is not there. But India still we are using those type of but some cases it has been changed premier industry, but it doesn't have that much market in India still now. But the regulation changes are going to happen. It's happening. People are talking on this regulatory body because lead content is more in can leach to the water. It's not a good scenario. Basically, Norail type PPO, because it is the same property, like it absorbs less moisture, it has a good impact strength, better operating temperature, all these things are there. Okay, weatherability is there, exposure to outside, all these things are there. So Norel PPO is used majorly. Norel is a trademark of SABIC. Okay, like Norel, other companies also there. This Zyron is there, Asahi. That's a competition to Norel. Okay, but it has been invented by SABIC. That's why Norel PPO is very famous. Okay. Then this is a water bottle application. Everybody knows the bottle is made of PET. Generally, PET is a it has a good mechanical strength. Okay, it can be blow molded. Okay, injection blow molded, and the cap is made of PP. Okay. And when we are, but the PET cannot withstand a boiling temperature of water. When we take a PET bottle to, hot or, immerse in, or we put some hot water, boiling water, it just, deforms. But PP, wherein PP, like feeding bottle of baby, or whatever PP bottles are there, if you put, and kettles are made of PP, because it can withstand boiling water. So if whenever we are selecting a bottle, when we go to a shopping mall and select water bottle, just, remember this: a PET bottle which looks like normal water bottle, it looks very nice, it looks better clarity and all, PET bottle. But if you want to put hot water, it just deforms, but PP will not deform. So PP bottle may not look that much, aesthetically appealing to PET bottle. PET bottle costly also when we go and see in the, but hot water, if you want to put, don't take these bottles. Okay, these are, HDP apply, like water tank and all. Normally HDP is done, and internally they'll be doing some coating. HDP application, and fillers will be there in this also. 30-40 percentage of filler will be there, because very cost sensitive, highly, it's bulk products. So that's why water tank and all. Even chemical tanks also made of the semi-crystalline. We cannot go for amorphous. That's the bottom line. These are some of the outdoor application. The outdoor, electrical lamps are there. So here I required a clear material or a diffuser. I hope everybody knew about diffuser. Diffuser is a metal in which there is a like a polycarbonate is there, which is transparent. But diffusion means I should transmit the light, but the light source should not be visible. It is like a LED bulb. I cannot see the LED inside, but the light of the LED should come out. This is known as diffusion effect. So for diffusion effect, no, there are diffusive additives are added to that polymer itself. It's a little bit costly. It is available, milky. It's not a normal, no, we are adding a master batch. It should conduct. There is a two compounds to a diffusive metal. One is the transmittancy, then is a diffusive. Normal case, whenever the diffusion or, this increases, transmittancy will reduce. So diffuser metal have a property which is a combined property. Both the properties a challenging application compared to normal, property. So these are diffuser, and over and above this has a outdoor exposure. If it stays any plastic, say for, with the outdoor application, after some time it loses, first of all the color changes happen, then the mechanical property, then all other properties. So outdoor application, the material, are designed in such a way that it's not, fade the color. Yellowish index, we used to tell yellowish index. The yellowishness should not come for a longer period of time. Then the haze, like it become a, some cloudy effect will come. It should not come. It should be, if it is a transparent, it should be transparent. In this case, you can see it should be transparent. These are roofing of, polycarbonate UV, sheets are used. It should not become yellow after some time. The color should not fade, or it should not become a milkish color after some time. So that is not a haze effect. One is yellowish effect, one is a haze effect. So both should not be there, and it has to withstand the higher temperature. Maybe 80, 70, 80 degrees. Sometime, spot temperature can come also. So all these things has to be, and like solar junction box connector, which, goes for a outdoor application for longer time, like we have spoken, 25 years and all service they're asking. So Norel, is used, which are having good weatherability properties. Okay, so how the raw material people test a weatherability? They cannot keep the raw material for 25 years, no. They cannot keep it for 25 years and validate and come to customer and tell, okay, this passes that. So weatherability equipments are there, which can create in the lab itself. It's an accelerated weathering. Normal, if it, atmosphere 40 degree or 35, 40 degree, the accelerated weathering means within short time, that much amount of energy light will be given to on the part, and cyclically it will be done. And after a cycle, 100 hour, 200 hour, something, heavy load of light, or no, this will be done by weathering. Suddenly water, it will be immersed in water, then again it will be heated. So it's an accelerator weathering will be done based on the output. It will be correlated, like 200 hours of xenon arc will be equivalent to 1 or 2 years of, like that we can correlate. The severe the testing, the more we get a data point, and based on that we can take a call. After that weathering, what they will be checking, whether this part has shifted its color. whether mechanical property has changed, whether electrical property before and after, what is the electrical property, what is the thermal property before and after. We'll be comparing all the things and coming on the table. Generally, safety factor is the more important than color, but many end customers see just a color. They feel no color shift, the property has changed. No, color shift may happen, but basically electrical mechanical property of the product will not change. That is how raw material people looks into that. More than color, they will not add any another color which will affect the mechanical property. And this color may change a little bit, but rest assured the electrical property, flammability property and mechanical property will be intact. That has to be kept in mind when we are designing. Okay, that is a major. Okay, this is a conductive. Everybody knows no metals are good conductor and plastics are bad conductor of electricity and thermal also. So this is the thermal conductive. Electric conductive, EMI shielding, that anti-static already we have discussed in the beginning, but this is a thermally conductive. Plastics are not at all thermally conductive. So how to make it a thermal conductor? There are some amount of like fillers or some amount of agents are added to the plastic so that they will become a thermally conductive, like stainless steel fiber, as I told. Also the carbon also is a thermally conductor. So it is a many people have their own proprietary things what they are added into that, and it become a thermally conductive thing. So whenever thermally conductive is, obviously it is hard to mold, difficult to mold compared to normal, because it will be hard to flow. All this problem will be there, and very very narrow processing window is there. And majorly these are used in LED, small LED application, because earlier people use aluminum heat sinks. Now to have a lot of fancy shapes and design freedom, people are going with some of the conductive plastic. But whatever may the reason, conductive plastic are not good as conductive as aluminum. Then how we can do the design? So design plays an important role here, the product design. We cannot just copy the same profile or features as the aluminum to this plastic, because conductive there will be if aluminum having a certain conductivity, this will have a 25 or 20% of that conductivity only. Then how to change that, how to do the design? Here in this case, the area of air contact, we will be doing this pin design. If aluminum we have a 4 pins, here we'll be taking we have to do a thermal FEA analysis to see that and design properly this type of product. Here we'll get a better productivity, mass production. All these things will be easy in this case, lower weight of the part. For this reason, we are shifting to plastic, small part. But this pin design and all has to be, thermal analysis has to be done. Area has to be increased. You can see multiple pins has been given to make it a more the area, more the conduction happens. No, because air goes there, and that conduction, convection, heat transfer happen by that way. Okay, convection, radiation. So area has to be in. That's how the design has been done. Because LED by itself, when we glow LED, bottom backside of the LED there will be heat generation, 80-90 degrees should be there. So if we should have a better life for the LED, if we are expecting a better life, that temperature has to be dissipated fastly. If you are accumulating that, the LED light will come down. If suppose I'm not removing the heat, the LED will blow off within 6 months. So I'm properly managing the temperature management done properly, then it stay for 3 years, 4 years, whatever it is. This is how it has been designed. These are some of the lighting application already we had discussed earlier also. First is optical type of application. These are these headlamps and all are polycarbonate, but this polycarbonate optical grade, because even small dot is not accepted. Optical grade means high, what I can say, quality. It's a polycarbonate itself, but it is manufactured in a completely controlled, like a medical type of atmosphere, controlled atmosphere. There will be no dust, nothing will be there. So it will known as optical grade of polycarbonate. Basic property molecules, everything remains the same, and it has a very good light transmittancy, like 90% of light, 92% of light. This is how whenever we are selecting electrical lighting grades, optical property in the data sheet will be added into that type of grade. So we have to see maximum 90 PMMA go up to 92, 92.5. That is a maximum. 100% of light in that 92 transmittancy is a maximum available. And then above that we require, then we have to go for glass only. Okay, plastic. A polycarbonate has a 90% and 91%. Okay, optical quality has a 91%. And this is the diffuser we were talking earlier. Transmittancy also should be there, but light source LED should not be visible. Then this. And tube lights, the same grade is we use, but this is injection molding, so we can go for a higher MFI grade. But tube light, this is an extrusion, then we cannot go for a higher flow or a higher MFI. Higher MFI means it is a like much towards a liquid, flow will be fast, so it will not be thin material. So thin material, if we extrude, it will sag, it cannot be extruded properly. It should have a strand strength. It is not a strand strength. So have a strand strength. We should use a metal which is having a lower flow, a higher viscosity, means lower MFI. Like normally for tube light applications, 6 to 8 or 5 to 8 MFI grades are being used. But for injection molding, 10, 18, 20 is being used. And here it comes in application where like LED lens is being used. Lens are like thick parts. Molding is, it's also optical grade of polycarbonate used generally. Sometimes PMMA also used for a lower type of application. But here molding is very, very critical because it's a thick part. Some lens are 20 mm thickness. Then it calls for different type of injection molding. It is known as injection compression. We will be injecting that machine itself is a customized machine or a different type of injection molding machine. So the initially the mold will be kept in a little bit open condition. The mold construction also totally different. It's not a normal mold. It have a vertical type of bearings and all. A little open condition. Then raw material will be injected to the mold. Okay, once it is injected, then the mold closes and compress the raw material again. Otherwise, this much thin type of article cannot be formed because sink mark, blow holes, everything will come with normal injection. So injection will be done, then the material will be compressed heavily, and this part is made. This is not an injection compression. So this lens type of part, okay, some people might have tried with normal engine because inside then we blow holes, big hole will come, a 20 mm, 30 mm thick part. It is done by injection compression molding. Now we are going for some painting and plating. Everybody is a common application in painting application. Normally, ABS are used. ABS in painting in scooter, automotive. Some of the car fenders, like fender of a car means front wheel side. There is a fender known as above the wheel. People are replaced with we are replaced with Norail also to reduce, because every day automotive industry is calling for a weight reduction for a better fuel efficiency. So they are trying to replace with plastic. Okay, having good mechanical strength, we have paintability also. Metals are very good paintable because they are conduction. It's a conductor, so it paint sticks properly to that. But plastic is a little bit difficult. But ABS and all can be done. But initially there will be primer coating will be there. First treatment will be there. Then second plating, coating, they'll do this painting. Okay, all the painting line. In every industry, automotive industry is a very is a little bit robust sort of process, because painting first, before painting we have to do molding, and painting as a last operation. If after painting something is getting rejected, means huge amount of cost we are going to lose. So to enable a proper painting or plating, we have to mold the part very best type of part has to be done, because any defect in the molding will get 10 times surface after painting or plating. So we feel painting or plating remove everything. No, some problem is there in the molding. It get highlighted after painting or plating, like anything. So whenever I used to attend issues in automotive, very critical, because normal parts look very good. After painting, it shows away, some marks are there, line marks are there, because in the molding the problem is there. Then we have to attend the gauge size, like I told proper filling, proper people inject by holding, give excess holding, the stress will be built. After the painting, that after some time that area properly cracks because stress is built. So proper gating, okay, in that I discuss shear rate when we are doing plating or painting should be very less. Normal ABS shear rate could be 50,000, but when we are going this secondary operation, because it's a chemical attack, secondary operation, this is going to this metal is going to severe condition, temperature, because after painting it has to be go to oven and cured in some temperature, or sometimes UV is going to get attacked on that, then that has to be molded lower shear rate and a better molding process. More temperature has to be paid. So whenever something secondary is going to happen, we have to be taken care in the mold and product design. So much care has to be taken. So these are some plating application. Normally ABS goes, and fender, I told no, in the fender ABS of SUV fender has been replaced with plastic related to metal sheet to reduce the weight, but they cannot go for ABS because it has a poor mechanism. Two-wheeler is a lower industry. These are a costly vehicle. And then Norail GTX, Norail combined with PPO combined with nylon 6.6 has been used, glass steel has been, because nylon has that repeatability, that impact strength, something comes, it has that property. But alone nylon cannot be used because it doesn't have a dimension stability. Then Norail is combined and has been used. But to have a painting, it cannot take the paint proper painting. Then conductive material has been added to that so that it can be painted properly. It's a polarization, basically polarization, creating some amount of polarization by putting conductive agent so the painting can be done. And this I already described, this ABS application. This absolutely, one is a electrical process, electrolysis process, other is a physical vapor process. Okay, thanks for explanation. Okay, one is anode cathode, as sir mentioned. One is anode and cathode. Due to that, electrolysis will be putting it in an electrolytic fluid. Due to that anode cathode, that metal will be accumulated. Other is a physical deposited. Other is a physical property, will be vapor of the metal will be getting deposited. It's a physical vapor deposition process. So these are some medical application in multiple lot of medical application we come across. Basically, in this application, majorly the regulation is biocompatibility application. As I told you, there are some application, rare application where the implant happens inside the body, so that a lot of regulations are there, which and very less raw material people take that risk to go for that. Okay, pure application. And syringe and all are made up of polypropylene because it has to be sterilized. We have discussed sterilization 100-degree and biocompatible type of where because blood is going to be in contact, so a type of material we use. Like otherwise this pouch and all is made of PVC, biocompatible type of PVC. Okay, PVC tubes are used. But in case of like instrument like monitoring, monitors, all these things, it requires some amount of impact strength also. So polycarbonate ABS blends, or if there is a chemical, like cleaning, lot of cleaning is going to come. They are cleaning with that fluid or whatever, anti microbial thing. Then it calls for PBT, PC alloys and all. But they are also most of the industry call for some bio FDA grade, sometimes food contact grade or biocompatible grades. And these type of pressure monitoring things are normal ABS type of product they are using. Okay, very cheap product. So these are some of the applications. There are multiple applications. When we think of, we have to narrow down based on the selection based yesterday what we have discussed, and come to a conclusion. A few more applications. This is a lubrication and low friction application. Generally for low friction, loaded application, continuous load application, semi-crystalline metal are always better because amorphous metal have a tendency to accumulate stress and crack. Okay, and semi-crystalline metal have a better, lower coefficient of friction. So generally, nylon and POM is the most commonly used material. But suppose we we have to go for a next level, more than that, then compounding comes to picture. Okay, in nylon there are nylons which have compounded special type of nylon, compounded with PTFE. PTFE have very low coefficient of friction. And I want a metal which is I want nylon proper. I want a metal which has a strength better than nylon. So what we'll do, we'll put some glass into that. We put a glass, the again lubricating property and friction, lubricating will reduce and friction will increase. Okay, it heats up and difficult. Then what PTFE is been added to compensate. PTFE or some fluid, lubricating fluid property additives are being added, so coefficient of friction will reduce. We go and see the data sheet. Any lubricating grade which is used, their positioning, raw material people are positioning for lubricating or frictionless application. You can see the coefficient of friction given in that. Okay, and we have to see that and select. And Delrin by or POM is by inheritance is a very good lubricant. Next, nylon also, but POM is better in that case. But again, go for a higher application. If you want to put glass filler into that, effect will come down. Okay, so we'll be adding like PTFE, polytetrafluoroethylene, Teflon. Okay, to that. PTFE is Teflon basically to that. But Teflon is not having better temperature property also. It doesn't melt also. So powder form of Teflon is being added and very good lubricating. So all these type of heavy type of gears, they use those type of materials. These are some aerospace application. Aerospace application, no, not due to severity sometimes. It is most regulatory driven thing, regulation driven thing, because aerospace, there should not be any chance of failure. So their safety factor is quite huge. Maybe ABS is required. The application calls for only ABS, but their safety factor is too much high. They will go for like Ultim or Peak, because it is a costly, but they don't want to take any risk. So they generally go for specialty type of higher grade of engineering classes, specialty, which are very costly position, very costly, have a extra high amount of performance more than required by the application. So aeroplane normally, when I was Sabik, we used to push a lot of like Ultim grades, okay, PI grades, but all are regulated by aerospace standard. FST standard are there. Then low smoke density standard. Lot of standards are if you go in deep. I'm not going too deep on that, but lot of standard driven. It is lot of regulation driven. Okay, even the food holding tray has a high standard of regulation. So these metal are like that, very costly. $100 a kg, $200 this size. And this is a fire alarm of aerospace application. This is also made by PI. Even I attended this product. Okay, it generally is supplied sometimes Honeywell and supplied to US market, because all the aeroplane manufacturers look like in the US, Europe, nothing in India. But part manufacturers are there. Okay, one of the manufacturers in Chennai was doing it. And inside this, the metallization is done, physical vapor metallization is done. Okay, to make it a conductive. Okay, these are a fire alarm. So some fire smoke comes, it will give an alarm. Okay, this is the connector of inside a aerospace application where the wires and connector comes. No, we have seen. So these are now high temperature. They keep, maybe temperature will not go to 200 degrees, but they keep select the raw material such a way that, and the mechanical property such a way that it can withstand any type of load or temperature. So Peak or PI Ultim is being used for mechanical performance, and it is having very high stringent amount of testing. Oh, loading, they will load with some 200 kilo, 300 kilo in a small part and see. So to withstand that, we have to use for specialty material only. And cold impact strength, they also see cold impact. If the material has a cold impact, okay, normally every plastic performance in their operation temperature. Some metal can go up to both. Every metal have a certain range of temperature can be operated, but there are some metal we can operate both in 200 degree and both in minus 40 degree. So these metal are meant to go for such severe application. So why? Because cold application is particular, because any material, if we take in a cold atmosphere, it becomes brittle. Everybody knows. Suppose have a scale, okay, which can bend. Keep the scale inside the freezer. Try yourself. Keep the scale inside the freezer for 10 hours, okay, highly cool inside the freezer, and take it and try to bend. It will break. But normally it can take more load. Am I clear? You're able to understand that application. So cold temperature impact, some metal has by its own, but some metal doesn't have. That's why copolymer comes into picture, okay, which can hold both minus 20 degree and 100 degree. Like Ultim can hold minus 40 degree and 200 degree. It's made like that. Okay, this is also one application which I not covered, but while speaking, it came into mouth. So whenever you are going and seeing a data sheet, you can see some particular metal which are intended to use in cold temperature. There will be multiple impact strength mentioned. What is a normal room temperature? One is elevated temperature. Third will be a cold impact like minus 20 or minus 40. So if you are designing some product for minus temperature, make sure that cold impact strength of that material is good enough. There will be a reduction, but make sure that it can take care of our application without failure. There are thousands of application and never ending applications are there, right? No, so these are some of the few applications came to my mind I put across. So whenever we are getting an application, as we are discussing our previous topic, downloading based on the application and properties of raw material, and we'll be able to get the proper selection. Okay, this polymer, this field is huge and vast like any field. Okay, so it takes a lot of time, understanding, and we can take support from the people and select a proper raw material and a cost effective. Okay, this is how that's it.